All right, this is 8th grade, Module 4, Lesson 26 on characterization of parallel lines. Now, as we all know, parallel lines are lines that never intersect. So a little different than what we did yesterday. So again, we have our two equations here, systems of equations, since there's a bracket there. And we're going to go ahead and graph these. Now, this is great. They're already in y equals mx plus b form, so we don't have to do any modifications. So this one, we are going to first start at 0, 4, because that's my b. And then my slope is 2, 3, which I'm going to rise 2, run 3. This one, we're going to start at 0, negative 3. And then my slope is 4, 6. So rise 4, run 6. So make sure you have your straight edge available. We're going to go 0, 4, put our first dot. And then we're going to go up 2. So 1, 2, run 3. 1, 2, 3. All right, let's do the next one. Now again, mine are not perfect because I'm not using a straight ruler or edge or ID card, whatever you have in your pocket there. Use it to help you get some straight lines here. All right, next one we're going to do 0, negative 3 down here. Rise 4. So 1, 2, 3, 4, run 6. 1, 2, 3, 4, 5, 6. And you got yourself a set of parallel lines. All right, so let's go down and answer A. A says identify the slope of each equation. And what did you notice? Well, we had 4 over 6 as that one slope. So the first slope we'll just write was 2/3. And then the second slope was 4 over 6. If I were to reduce that, I would get 2/3. So what do we notice here about our slopes? They're the same. So they have the same slope. And since they have the same slope, they're going to be parallel lines. Identify the y-intercept of each point. All right. Well, we wrote that up above, but here we go. The first one was 0, 4. And the second one was 0, negative 3. And again, y-intercept, that's your b. All right, let's go down to the next one. All right, if you notice that they do already have these in our systems of equation format with the y equals mx plus b. You can easily see that we do have the same slope here. It's drop 5, run 4, because we have a negative there. But here we're going to start at 0, 7, and here we're going to start at 0, 2. All right, I'm going to graph the first one. We have 0, 7 way up here. Drop 5, run 4. So 1, 2, 5. Now run 4. 1, 2, 4. So right about there. Hopefully yours looks a lot better than mine. I'm going to graph the next one, 0, 2. Drop 5, run 4 again. And make those lines nice and straight. So identify the slope of each equation. It was negative 5/4. And again, we're going to say it was the same slope. And what was my y-intercept? We had 0, 7 and then 0, 2. All right, let's go ahead and go on to the back. For the back, you guys are going to complete number 3, and that's 3A and B. And you may pause the video at this time so you can work those out, and then I will help you back out with number 4. Number 4, write a systems of equations that have no solution. So there could be several different answers here, but no solution. No solution means they do not connect. They don't intersect. So our parallel lines. Parallel lines have no solution. So basically, I just need to write 2 equations, systems of equations. So I'm going to use my bracket. I'm going to say y equals 3/4 x plus 1, y equals 3/4 x minus 2. It doesn't matter. The only thing that matters is if these have no solution, that means my slopes have to be identical or reduced down to the same amount. Now, write a systems of equations that give you a 2, 1 as a solution. So you want where they intersect at 2, 1. All right, I'm going to let you talk that one out with a friend. So if you want to pause the video real quick, I want to know what are two lines that when you intersect, they do intersect at 2, 1. So you have to give me a slope and a starting point. How can you tell if a system of equations has no solution or not? Well, have you noticed here, you had to have a different, whoops, my pen just decided to go crazy there, different slopes. If they have different slopes, then they will intersect. If they have the same slope, then they will not. So let's write that down. If the slopes are different, the lines will intersect. If the slopes are the same, the lines are parallel. All right, there you go. Number 7, does the system of linear equations shown below have a solution? All right, let's find out. So I'm going to erase this real quick and pull it up. First, I want to make sure that they're in y equals mx plus b form, and as you notice, neither one of them are, so we need to fix that first. Now I want this y on this side, so I'm going to move that 6x by subtracting it from both sides. And I get negative 2y, and again, you want your constant and your x first, so even though the 5 was there, bump it over. Excuse me. Now we want to divide out that negative 2, again, to get that y by itself, and you divide out that negative 2 to both numbers over here. So your ending result here will be y equals 2 goes into 6 3 times. A negative and a negative is a positive. The x remains. And then here we'll have minus 5 over 2. So that's my new equation there. The next one, we have 4x minus 3y equals 5. I'm going to move that 4x. Excuse me. Bring down that negative 3y minus 4x and bump that 5 over. Divide everything by negative 3 to get that y by itself. And we get y equals 4 over 3. And the negative become a positive. X minus 5/3. So real quick, easy way. Will it have a solution? Well, what's my slope here? 3. What's my slope over here? 4 over 3. So will this one have a solution? Yes. How do I know? My slopes are different. All right, I want you to try 8 with a partner. All right, let's look at number 9. Number 9 is again asking you, does the system of linear equations shown have a solution? All right, so again, you want to make sure that you're putting these in y equals mx plus b form. I'm going to let you also solve number 9, but I will, before you do that, let's do number 10. So it says Jenny babysits for 2 different families. One family pays her $6 each hour and a bonus of $20 at the end of the night. The other family pays her $3 every half hour and a bonus of $25 at the end of the night. Write and solve the systems of equations that represent this situation. At what number of hours do the 2 families pay the same for babysitting? All right, here we go. So we have an equation. Let's solve the first one. She gets $6 an hour plus an additional 20 at the end. So we're just going to say y equals that. There's my first equation. The next one is she gets $3 every half hour. Well, since this one's per hour, let's go ahead and make that per hour. So if she's getting $3 for a half hour, how much is she getting for 1 whole hour? 6. So this will be 6x, but she gets an additional $25 at the end of that night. I don't even need to solve this because the question's asking, at what hours do the 2 families pay the same? If they're paying the same, that means they intersected. Excuse me. I think my son is getting me sick. All right. Now, since my slopes are the same, as I die in the middle of this video, since the slopes are the same, that means they're parallel. And if they're parallel, then they'll never intersect. So we're just going to say same slope. So there's no intersection. This is not a point where she will be paid the same by both families. All right, and that ends this video.